So this is another attempt at things not working how I want them to, but we're going to try and make this video for you anyway. Right now we're going to be talking about factoring and the greatest common factor, as well as grouping. So I'm going to ask that you kind of pay attention to the screen here as we work on these. So first of all, we would be able to find the greatest common factor. So recently we've already worked on trying to find the greatest common factor of these items. So we could do their prime factorization, factor them completely, and we would have a 3 times 3 times x right here. And this would be a -1 times 3 times x. From here, we're going to see what they have in common. They both have a 3, and they both have an x. So that is my GCF. My GCF is 3x. So once we find that GCF, we need to write that out in front, and we're going to basically try to see what's left. So if I took 9x squared divided by 3x, or we could be looking at what's left over here, right? We would be left with another 3x and a -1. Okay? So we did the prime factorization, found they had a 3x in common, and then we divided it. Okay, so that's what we're looking at for that example. Let's try another one that has 3 terms. Okay, so we could zoom in and see how we factor each of these. So 55p squared is like a 5 times 11 times p times p. This is a -1 times 11, and we have 4 of these. And this would be a 2 times 2 times 11 and 5 p's. Okay, so I'm going to highlight what they have in common. It looks like as far as numbers go, they all have an 11. As far as variables go, they all have 1p, and they all have a second variable of p, but that's it. So my GCF here is actually going to be this 11p squared. And then we're going to divide by that. So if we take 55p squared divided by 11p squared, what we're left with is the only factor that's not written down yet. It's not highlighted, which is the 5. In the middle, we're left with a -1p squared. If you wanted to, you could just write that as a negative, up to you. And then we would have over on the right, we have a 2 times 2, which is a +4p to the 3rd power. And this is how you factor out the greatest common factor. Okay? So moving on, you should be able to do this one and come up with the answer. So pause the video and go from there. Okay? So your variables don't always have to be in the common or your numbers. It could just be one part or the other. So greatest common factor out, you find the greatest common factor, and then you actually have to divide that out. That's what factoring means. So next, what we would have is, if we have 4 terms, we're going to call this grouping. So notice that there is nothing that all of these terms have in common. And that's why we come up with this other strategy. Okay, so they have nothing in common at all. And so we're going to be looking at splitting it in half. So here are some strategies here with the same problem. First thing we want to do is we want to split this in half and look for the GCF of each half. So what I'm talking about is, pretend that we split this right there. We want to find the GCF of 6y squared and a -4y. So that's going to be a 2y. And if I factor that GCF out of the first half, I would have 3y minus 2. Okay? If I look at the second half, it looks like they have nothing in common, which we call relatively prime. And when we did greatest common factor, we had relatively prime. We say, well, the only thing that divides both of those is a +1. So if I take anything divided by 1, it's itself 3y minus 2. So we split it in half. We factor the GCF of each half. And what do you notice about what we have there? Okay, what we have is everything in the parentheses is the same. Do you notice that? So if you look at each half, what we have is that each of these is the same. So what they now have in common is this 3y minus 2. Right? Now this is the greatest common factor of those two terms. And what we're left with is a 2y plus 1. That is grouping. So grouping is the greatest common factor, but we split it into smaller pieces. We chunk it as far as that goes. Okay? So let's look at this one. There is no GCF overall. The beginning looks like we're going to have some M's or some N's, but nothing in common overall. So we're going to split it in half. Take out the GCF of each half. If it still helps you to do this, that's fine. There's nothing wrong with that. Keep things at the level you understand it. Okay? We'd say they both have 2's and an M. Okay? We can still do that. There's nothing wrong. If I divide by that, what I'm left with is an M plus N. On the other side, what they have in common is they both have this negative 1. So I'm going to go ahead and do that. And usually, if this term right here is a negative, you want to take the negative 1 out. Because we want everything to match. What else matched? What else matched? 3 matched, and they both had an N. So I would have negative 1 times 3, negative 3, N, which leaves me with an M and a positive N. Okay? As desired, since we're doing negative out, everything inside of here matches. So that is my new GCF, is the M plus N, that binomial. And we're left with 4M minus 3N as our final answer right there. Okay, so as far as factoring goes, GCF and grouping, that's what we're looking at. Okay. As far as solving with these, first of all, these steps, sometimes these steps right here, you're going to want to write these down somewhere. These steps are basically going to stay about the same this entire chapter. But with the factoring completely, we're going to come up with different strategies and different tools on how to factor. Okay, so we're going to continue to build up that toolbox from there. So we're going to want to set our equation equal to 0 in descending order. Step 1. Step 2, factor completely. So right now, our toolbox is GCF, or grouping, and then set each factor equal to 0 and solve. Okay, so let's look at this particular problem. Step 1, set equal to 0. Well, technically that's already done. Step 2, factor completely, right? That's already done. Step 3, well, the reason that step 3 is to set each factor equal to 0 is because if you are multiplying two things, okay, and their answer is a 0, what we know about that is our zero product property, that one of these has to equal 0. I don't know which one, so we're going to find both cases. So that means either 3y minus 4 is going to equal 0, or 2y plus 5 equals 0. So then we solve it like we normally would. We're going to go ahead and we're going to add the 4 over and divide by 3. We go ahead and subtract the 5 over and divide by 2. So you could write this as improper fractions. You could write it as mixed numbers. You could write it as decimals. That's really up to you. So 1 1/3 or 2 1/2. So this right here, as far as the steps go, it's not factored yet. Set equal to 0 in descending order. Step 1, check. Factor, we have to factor that. So there's not 4 terms, so we're looking at the GCF. We're not looking at grouping. GCF of 4y squared minus 12y. I could do the prime factorization. So they both have 2, and y, which leaves us with 4y times y minus 3 equals 0. So now it's factored. Check. Step 3, set each factor factor equal to 0 and solve. So we're going to have this be either 4y is equal to 0 or y minus 3 equals 0. And we're going to solve that. If I take and I divide 0 by 4, that's 0. If I am subtracting 3 into the inverse, which is to add 3 to the other side, then that would be a 3. So my final answer is y equals 0, or it could be a 3, and that would make the original equation true. We can always double check that, right? We can always double check that. If this is a 0, is 4 times 0 minus 12 times 0, 0? Absolutely. If this was a 3, 4 times 3 squared, 4 times 9 is 36. 12 times 3 is 36, so 36 minus 36 is 0. So we know that our answer works. We can still check that, okay? And that is what we're looking at for today. We are factoring and solving using a greatest common factor and grouping.